Yes, hello everybody. In this section I will show you how to add color fill and borders in select cells, and also how to remove the color fill and borders from those cells, and also remove the content in order to reset an array. In the next page of the PowerPoint here, you can see an outline of the operations we do. I got them by Googling, how to add color in a cell, VBA, how to add borders, how to remove borders, VBA. Okay, let's get rid of this and go ahead, open the old Excel file that we worked in the first section, in the first part of the first video. And here's the same thing that we did. Let's delete this. Oh, let me just repeat, look at this. This macro is very important because it generates in a 6x6 array a random number between -1, 0 and 1. This random number can have, with equal probability, 3 values: -1, 0 and 1. It's very, very important because we will use it a lot in order to describe a molecule which can go either right one step, stay in the place, or go left one step with equal probability. Alright, so let's go ahead, delete this chart, we don't need it, copy one of these macros, okay, copy, and paste it, Control V, and let's call it, we cannot leave the same name, let's call nested for loop color fill. Okay, and here we go to Google and say how to color fill cells VBA, or how to color cells. So it's not so strict how you do the query. I just type this, how to color fill VBA, and then go in and copy this little thing, copy. Okay, let's look here. You see range A1, we already have described it as I believe B2 offset something, and then we add dot interior dot color index dot 37. Maybe not 37, let's look further what options we have, but for now let's just copy this, Control C, and go here and put it right after offset. Okay, Control V. Okay, so remove this range because we already have the range. Range is B2 offset, and then color index 37. And let's look here. Let's work with I like 9 by 9, so 0 to 8, 0 to 8. Okay, and you see this is 9 by 9. Make it you know what, let's make it kind of square. Okay, delete this and zoom in a little bit, so control and scroll the mouse button, and let's run this. Okay, so we got some color here. Okay, 37. Now I'm going back and say colors VBA. We're trying to see some numbers we can plug in there. Okay, and there's two ways. There's a how do you say, a detailed way with a lot of precision, say 256, which is I believe 8-bit. You can have 24-bit of describing a color, or this table here, which shows just I don't know, I think 56 colors. Easy way. Let's use the easy way because I don't want to confuse anybody for now with very detailed, RGB and stuff like this. So come here, and I like you see, let's say 19 for the background and 3 for the if we have any atoms. 3 is red and 19 is like a cream, light yellowish kind of thing. So let's do this. Let's put 3 here for now, run it again, boom, and it's red. Okay, I want you guys to remember, for almost any programming you do, Once you have integer numbers, divisions, we want to find out the remainder of that, you use a function called modulo. Not modulus. Modulus is something else, usually absolute value. Modulo. So let's say 2 modulo 2 is 0, or 5 modulo 2 is 1. So divide the number, the argument of the function, by the modulo number. So 5 divided by 2 is what? Is 2, and there's 1 remainder, so it's 1. So let's put here, instead of this, let's put for j is equal to 0 to 8, for I equal to 0 to 8, if, okay, if I is equal to, I mod 2 is equal to 0, so if I is even, and j modulo 2 is equal to 0, then we have that. Okay, well, then we forgot then. Okay, and of course there is an else, and else we put we copy this, paste the same thing here, and set this tree to, I said 19. Okay, where is that? 19. Okay, and then of course you need to put and if. I think it's separated, but I think the VBA editor was separate. Yeah, so we selectively colored every other cell, so with a periodicity of 2 in red, leave the rest kind of a cream. Okay, let's run this and see what happens. Okay, so it's good. What I don't like is that this is not quite square. Let's make this let's make this 10. Okay, it looks better, and run it again. Oops. Okay, again I want to bring them square. Okay, so I put this and make it like this. Okay, so all right, another thing I want to show you, let's say here, let's copy this. Okay, copy this, call this 1. Okay, and make another one, Control V, color to fill. Okay, let's say if I is equal to 0, or I is equal to 10. Okay, or j is equal to 0, or j is equal to 10, then we get this red, and the rest we get 19. What this, okay, we forgot then. Okay, so if I is equal to 0, okay, this is I equal to 0. If I is equal to 10, or j is equal to 0, or j is equal to 10. So what you get, you will get an all yellow as a cream square with red edges. Okay, so let's run this. Okay, that's what you got. So you can do all kind of tricks. Okay, you can do, yeah. So for now, let's copy this again. Okay, copy, and paste it here. Let's do some border drawing. Okay, border drawing means you know, you have, oh, let me close this. Okay, so if you select something and you go here and say, oh, the border, you have a border. Okay, So, or you can go no border, okay? So let's draw borders around those things. Now, I want to run this macro again with 0, 0. 0, 0 means no color, okay? So let's just clear it, okay? Oh, there's an ambiguity. Let me see. Loop color field 2, 3. Let's put 3 here. No, let's put 1 and not color. Let's let's put border. So this macro here is work in progress. Don't worry about this. Let's look at this. I changed it to 0, 0, run it again, so it disappeared, okay? So let's go to loop border. Let's run it again with 19, 19, okay? So it's yellow now, okay, good. And now let's draw borders here, and I type add cell borders VBA using VBA. How to add cell borders using VBA, and I kind of like this one, okay? It's very simple, and again copy. If I zoom in, the range is already defined in our case, is A2 offset something, and then we will follow with this. So we will only copy actually this part, okay? Copy, okay? Control 0, we'll rezoom it to the 100%. Then we go here and let's say Control V, okay? And delete this stuff, okay? Let's see what happens here. So loop border 1. Actually, we don't need one. We just build one macro, okay? So I'm here. I'm gonna do this like that and run the macro. Oh, well, we forgot this. So Control C, Control V, and we need to you see this this means is an error running, so we click here and there's no more error. Run it, boom. Okay, do you like it? Yes, I think it's cool. If I put here 3, okay, 3 modulo 3, every third cell will be surrounded with a border. Run it, and there will be a problem. I will invite you to think about, there will be a problem, because if we just do this, we keep the borders, we didn't delete the borders, okay? So let's run it, okay? Okay, see? Houston, we have a problem, okay? So what we do, we can put else, and then use the same thing, Control C, Control V, and I already did search before how to delete border, and you put none, okay? So let's run it, okay? You see, that's what you have. Let's put here 4 maybe, yeah, 4 modulo 4. Every 4th cell is surrounded by borders. Run it. Let's go back to 2, okay? 2. Let's also introduce in the bordered cell surrounded by border, introduce a color. Let's say copy this and put paste it here. Let's put color 3, okay? And the rest, Control V, let's leave color 19. Let's run it again, okay? So now you have color and border. And also let's do this, Control V, let's put a number, okay? Let's say red, no, R for red. And here Control C, Control V, let's put 0, okay? Oh, let's put X, okay? So tic-tac-toe, okay? Oh, wait a minute, it doesn't work because R is a string, is not a number. So if it's a, okay, if you put say 3 and 2, it will work, okay? But if it's a string, you need to put, like we saw in the other video, you need to put quotation marks, okay? R, and here x. Okay, run this again, and or here we can just put nothing. Okay, just quotation marks. So we have this. Okay, so another thing, I did a search. I'm not gonna waste time anymore, but how to clear, that's how you clear it. Okay, so let's take this, copy, and let's say when we run this, before we run anything, we can clear it. Control V. Okay, and if we clear it, then we don't necessarily need to put this. So we keep a clear cell everywhere else except in these select locations where we have red, we have border, and we have an R. So for each iteration of the loop, we clear the cells. So of course, instead of that, we use this range. Okay, Control V, Control V, Control V. So let's run this and see this, how it works. Okay, so removed, we put an R on a red background with a border, and in the rest we just didn't do anything because during each iteration we first clear the whole array. Another thing, I would like to take this and Control C and write another sub. So sub clear, or clear, let's say 77. I don't know. We will use another clear example. Oops, sub, no underscore. Okay, sub clear. Okay, and we can use this stuff here. Okay, Control C, Control V, and let's put from B2 to L12. Okay, so here we have B2 colon L12. Okay, Control C, and here Control V, Control V. Okay, so let's run this. Boom, so we clear. So this is the clear macro. Okay, so thank you. I will see you in the next section. Yes, in this subsection we will be talking about how to animate a vibrating atom, or perhaps two. Okay, this shows a lot of people get stuck here because they can calculate amazing things, but they always wonder how to do the animation. So let's close this presentation and go back to our spreadsheet. I deleted, the array we had here, and we're gonna copy one of these macros here. Let's say this one. Okay, copy and paste it here. Let's call this vibrating atom. Vibrating atom. Okay, so in this case we have the vibrating atom colored in red and the rest colored in this cream, this yellowish thing. Okay, 11 by 11 is good because we can put there is a middle. The middle is starting from 0 to 10 is 11. The middle will be 5. Okay, and let's generate two random numbers. We are going back a few macros, and you see this formula. This is very, very important. Okay, copy this int of 3 times rand minus 1 generates either a -1, a 0, or a +1 with equal probability, 33.3%. So let's put this here, Control V, and create an M a variable m, integer, and also an n, control V, an n. So this will be a pair of integer numbers between -1 to 1. Oh, you see, I already put them here, as declared them as variable. Since they can be only between -1 and 1, I think integer is enough. But again, nowadays the memory of computer is so big that it doesn't matter. You can put long, you can put super long, whatever. There's no super long, of course. Okay, so we do this. We declare m and n as integer. We calculate them between -1 and 1. And also here we say if I is equal to 5, we decided the middle of the area of our area here, 11 by 11 is 5, 5, 5. Starting from 0, 5 plus m. I always like to start with j, actually, j. And also copy this, control C, and control V, I is equal to 5 plus n. Okay? Then we made this red. If not, we leave everything to 19. Okay? So let's run this once and see what's going on. Okay? So if we keep hitting this button, you see this kind of vibrates in 9 different, because you have 3 outcomes here, times 3 outcomes, you have 9 outcomes. It can be anywhere anywhere between the middle and its 8 neighbors. So let's keep hitting this. You know, you see that's the middle, what I highlighted there. Now let's create another another macro, control C, that does this serially, animated, control V. Okay, and let's say vibrating atom, animated. Actually, animated vibrating atom. Okay, and how we do that? We will insert another loop, control C, and put this here, control V. For S, we declare another long, 0 to, let's say, 200. Okay, and then next S. And again, I should go up here, up on the top with the variable declaration, control C, control V, and put S. And definitely this should be long, because sometimes we might want to run thousands of cycles. Okay, so let's see how this does. Okay, so I put the cursor, I place the cursor here and run it. Okay, see, I highlighted the middle, so it runs around that point. Let's do another trick. Let's create a macro. You go to any shape. Okay, you can go auto shapes, basic shapes, whatever you choose. You like this smiley face. Okay, put a smiley face here. Also, you can write run inside, double click, alignment, put center. You can go color and lines, fill, you can put it this, and let's increase the font here and put it red and set it red. Okay, so, and then right click and say assign macro and say animated vibrating atom. Okay, and hit. It's running. Okay, now if you want to stop, there are better ways. We can use the same button to stop it, but for now I don't want to overload your mind now. Just when you run it, you can hit escape. Hold escape down, it's gonna stop. You're gonna come with a little error, but you say end. Okay, so this is the end of this section. Actually, let's do it again so people remember. You pick up any shape, okay, any shape, basic shape. Let's say take this, write something, the title, the name of the macro, okay. You can, you know, change colors or whatever, alignment, center, and then highlight it, right click, assign macro, and choose the macro. You see animated vibrating atom, animated vibrating atom, okay, and then you can run it. So what we did in this section, I show you how to generate two random numbers, one for vertical, one for horizontal, add them to a fix to the center of the array. So you either add a 1 or subtract a 1 or a 0, and then move these, throw these two dices to these two dice for each cycle, and actually we don't have cycle here. We throw the dices, we decide what M and N are, add them to 5, which is the center of the array, as an offset, and then color that pixel in red, and the rest leave them yellow. And in the second macro we added another level of looping, nested 3 loops, and the first loop, the outer loop, is essentially the animation loop from 0 to 200. Okay, thank you. Let's talk now about the real atom array movement, how we can create an array of atoms with certain spacing, periodic spacing, put it in a square enclosure and move it around, first unrestricted by the walls and then restricted, bouncing off the walls. Let's go to the next page. I want you to, I'm gonna pause here for maybe 10-20 seconds. I'm gonna talk about this, explain you why you need two arrays. You need an atom array and an atom change. You can also call it, say, the measurement array and the change array. You don't want to do changes in the atom array. You want to measure, do all the measurement, detect where the atoms are, how many atoms you have in each node. In some nodes you won't have any atoms, and then do the change in the atoms change array, and then you add them together, find the final at a new iteration of the atoms array. Okay, so this being said, I'm gonna exit the presentation and try to explain it as much as possible with my own words, because that's where the problem is. When I tried to solve this problem first time, I got a tremendously strange multiplication number of atoms. I was getting a lot of them, starting with 10 and get 100 after a few iterations, because I didn't understand it. So I figured out, okay, so the scan, whenever you look into an array, you start from the right and go to the left pretty fast, and then you turn around, go to the next line, down, and again scan. Is there an atom here? Is there an atom here? Is there an atom here? And then turn again. When you find one, you stop and say this atom will have to move either in these 9 directions, in these 8 directions, or stay on the spot with equal probability. Let's say about, I believe, 11%. So there's an 11% chance that this atom will stay here, or 11% it will move across along these arrows, with these arrows. Okay, now the array being done the way it is done, right, left, up, down. So right, left, fast, up, down, slow. If you got here with a scan and you detect, oh, there's finally a non-zero location, an atom there, let's say it's a one atom, and then you say, okay, I'm gonna throw these two dice, you know, and get one of these 9 opportunities. If you move along this arrow or this arrow or this arrow or this, so if you move in the past where you already scanned, there's no problem. But if you move in the future, when the scan proceeds and finds this atom here, it takes it like not a moved atom, it takes like, oh, there's an atom here, so it multiplies. Not good. So you need to add two arrays the same size, one called atoms, one called atoms change. In this first array atoms, you will do measurements. In this atom change, you will do changes. You will keep track of the changes. And then at the end, after you finish scanning everything, you add them together and you get the new iteration of the atoms. And again, not only you get the new iteration, you turn this to 0 again, you reset this. So each cycle you measure this, you change and find a new atom change, then at the end you add them together, you keep these atoms and delete, I mean not delete, reset everything here. So here are the formulas, you know. If you find an atom that is not 0, the atom change, the new atom change will be equal to atoms minus 1, because the atom leaves, okay, in a different direction, or stays, but you will see this also keeps into account that possibility. And then atom change of the same location plus some random offset factors, which can be -1, 0, or +1. So atom change in the new location, you add 1. So you model the leaving atom by subtracting, and you model the coming atom by adding 1 here, okay? And again, you come here and read this a few times, you're gonna get it. And then at the end, atoms, you add atom change to atom, find out the new atoms, and also reset, I mean clear atoms change. Okay, so these are two. So after you calculated atoms change, you add it with atoms, find the new atoms, the new iteration of the atom array, and also clear atom change. Good, so you can go back and see this. Let's go to our spreadsheet here and create a macro that offsets the array, that sets the array. Let's see, oh, I like this one, okay? So let's copy this and paste it here and call it set array. Okay, set array, and let's say from j from 0 to 20, okay, I from 0 to 20, okay. I like this 20 number, and again, this doesn't need to be 20. You can make it, you can put a cell, you can write in this cell, let's say in n21 20, and put n21 in square brackets and get the same thing. But let's do now, fix this easier, not to confuse people. So if I, okay, then color index is 3, and also I want to add an atom in this location, okay? So let's first declare two arrays, okay? Dim atoms as long, okay? And Control C and paste this. Atoms change as long, okay? So here let's copy this, okay? And that's just a generic declaration. You declare the size right here as redim, okay? Oops. Atoms 1 to 20, comma 1 to 20. So we redeclare, give the real dimension here, okay? Just just remember this, I did some searches, Control C, Control V, and you don't need to put as long, you already declared this. Okay, readings, atoms, change. Okay, so let's say here you're not only changing the color of the where you have atoms, but you also put atoms of J I is equal to 1. Okay, and atoms okay, and also here for each of these you put atoms atoms. Okay, let me see. Atoms J1 is equal to 1. Atoms change is equal to 0. Okay, and I think that's what you have. Also, you need to put this atoms JK, Control C here is equal to 0. Okay, so what you have here is not only filling with color. Wherever you put red, you go to atoms array and put inside, put a 1, so it's an atom, one atom there to start with, and also in the rest where you have this yellowish creamish thing, you put a 0, and you also put a, you set this to 19, which is a cream color. Okay, let's run this thing. Okay, subscript out of range. Let me see, there's something here funny. Oh, it's 0 here. Okay, 0 0 0 0. Okay, so to match this with this, let's run it. Okay, so you got this. Let's select this, and that's about right. Move this out of the way and zoom in. So I hold the control key and roll the mouse little wheel there in the middle. So, and also okay, let's copy this, paste it here and call it set. Okay, and assign macro set. I'm trying to find it, set array. Okay, so no matter what I do here, okay, let's say no fill. Now if I set it, boom, it fills it. And this run, we're gonna associate it with a different macro. I like to select the color of this, maybe something reddish, that's too dark. Let's put this, it's a purple. Okay, set, and also run. I'm gonna make it smaller, but we are not gonna reassign a macro yet. We need to write the macro. Run, I usually like to set it green, yeah. So certainly I like oops, oh, undo, what did I do here? Okay, oops. So all right, another thing. There was an error. I don't want to remake this video for this. In this slide that I left it there for maybe half a minute, you need to replace atoms with atoms change. You don't do changes on the atom array, you only do changes on the atom change. So atoms change ji is equal to atoms change ji minus 1. At the very end, once you finish scanning the whole thing, then you can reset this, clear this atoms change, and also you can add atoms, the old atoms to atom change, and get the new iteration of the atoms. Now let's go back and figure out how to write a macro to move these molecules around. First, unbound. Okay, so I'm gonna go here and copy, let me see, copy this one. Okay, copy. This shows, this creates a color field, and let's paste it here and do array, rename it array movement, and so from 0 to 20, and actually I should have picked up the one with a loop, so let's try the loop ourselves. For s is equal to, for s equal to 0, no, equals to 1, because these are cycles, to 50, let's say. Okay, first thing, you need to generate two random numbers. We are gonna copy them from here. Okay, copy and paste them here. Okay, and actually that's not the right place to paste it. Control X. We need to paste them in the loops here. Okay, so right here, for each ij in the loop, you need to create those two numbers, two random numbers, which shows the molecule, I mean the atom, where to move randomly, right, left, up, down, control, or stay on the spot. Control V. So you have this. If we look back to our slide, what we need to do, we need to have, if we find an atom, okay, we need to change atom change the ij and atom change of the random coordinates. Subtract from the first location, add to the next, to the moved location. Okay, so we go back here and say atoms of atoms change, actually, of ji is equal to, Control C, atom change of j1 minus 1. But we do this only if atoms change, atoms is great of ji is greater than 0. Okay, then we do this. We throw the two dice, and we change this. And another thing we need to do, move the whole thing randomly, offset them by these values. Okay, and add 1. So I'm sorry, I need to I need to copy the whole thing, Control C, Control V, change, plus M, plus N, and here plus N, M, and plus N, and plus 1. So what we did here, okay, let me end if, okay. So what we did here, while we scan this array, okay, let's indent it first, so it looks better. So while we scan this array, every time we get to a new location, we do what? We check if there's an atom that is there, so it's bigger than 0. If the number is 1 or more, then we do something. We throw 2 dice, an M and N, which can vary between each one can vary with equal probability between -1, 0, and 1, and go to atoms change and operate 2 modification. In the location where the atom is non-zero, subtract an atom, and in the new location that is obtained by offsetting with a random number, vertical and horizontal, we add an atom. So we subtract an atom from the original location, we add an atom to the new location, okay? And do this as a loop, 20 by 20. So you might end up with atoms, 2 atoms or more atoms in the same location, you know. Technically you can have, what, 9 atoms in the right condition. And of course, later we will add polymerization. So if there's more than one, we'll say, oh, generate a polymer, and for each polymer subtract 2 atoms from that location. But for now, it's good enough. So this calculates atoms change, and let's pick this up and copy, create a loop to generate the new atoms array by adding the old atoms with a change, resetting the change array, and displaying the result. So Control V, okay. So for J, oh, you know what, I like this. For J, okay, we don't need this, okay. Actually, let's operate that later. For now, let's do atoms Ji is equal to the old atoms Ji plus atoms change of Ji. Okay, we did this, and also let's clear atoms change, okay. Control C, Control V is equal to 0. So this is setting the new, deriving the new atoms and clearing the change, you know, the temporary memory, clearing that. And now, so this is we call this set, reset, whatever. And here let's call this display. Okay, this is the display, and the display if atoms of Ji, now this is the atoms, okay. If atoms of Ji greater than 0, then display it with a let's go pick up the display macro here, the display statement, okay. Copy, okay, 319, then Control V. So B2 offset blah blah blah, color index is 3, okay. So we display a red there, okay. And let me see, else we put this code 19. So this is a red, code 3 is a red, Control C, and 19 is a cream, like almost white. Okay, so this is it. Next I, next J, and we need to say next S. This is the animation loop. Okay, so right now the movement is array movement. Let's call unrestricted. Okay, so right now you might get into off the bounds. You know, I don't know exactly what happens, but hopefully it's not going to crash. So let's run this. Open this and run it. Okay, subscript out of range. Alright, so we tried to run the array and I had problems. I got this subscript out of range, something like this. I found two errors. Here it instead of m, instead of n was m, and also since this is unbound, unrestricted, it might go from 0 to -1 or from 20 to 21, and I changed this part here. From instead of 0 to 20 I put just for declaration, you know, you don't need to worry. Once we bind the array, we don't need to worry. We put it 0 to 20, but now I put it from, I set it from -1 instead from 0, from -1 to 21 instead of 0 to 20, I set it from -1 to 21, everything. And now it runs. Another thing I did, I put a statement, do events. After these loops run and all the new, display, all the atoms, the position of the new position of the atoms is displayed, I allow the program to stop a little bit and operate, update the screen. So this is what do events does. Otherwise it will run and you won't see any change until the macro stops, then it displays. So let's run this. Okay, oops, there's some problem here, and let me see, from set, wait, this this runs only 10th of the array somewhere, somehow. So 10 to 20, 10 to 20, let me see, 10 to 20. I'm gonna interrupt this for a second. So I looked at it, I couldn't find any problem. I added these do events here at the beginning of the S loop and at the end. So now it runs right. So we run it. Okay, actually let's assign macro and unrestricted. Let's see, unrestricted is in alphabetical order, I believe. Okay, so so they move. Okay, now some of them will pass out, somewhere will go, you have a leak because it's unbound, so some of them go away. If you go, say, 500, if you set this to 500 and reset the array and run it, by the end of 500 probably a lot of these atoms will be gone. Okay, but you can see them moving. And the next step we will do, you see, is already out of atoms. The atoms are actually lying somewhere just on the first, on the edge here, just one cell away from the, let's end this, set, and insert restriction. Okay, all right, so let's see what how we can restrict the movement of the atoms between the bounds of 0 and 20. So 21 by 21, 0 here and 20 here. So let's copy this macro, and there's different ways we can do it, but essentially I found a way which is very, very easy. Okay, so the idea is there is a dice casting here. So you take two dice, M and N, and cast them and get minus 1, 0, and 1. Okay. Then you add this. You see, you add this M and N to the indices. If these values J plus N and I plus J plus M and I plus M fall outside the bounds, we cast this again. So we do a loop, okay, an infinite loop, a do loop. Okay, so do, and the do loop usually ends with loop. Okay, I'm gonna separate this so you can see. Here it starts bounding, wall bounding, okay, and here ends also wall bounding. Control C, Control V. So wall bounding is here. Do, and then if let's take these two values, okay, Control C, Control V, okay, J plus M greater or equal than 0, and this also greater than equal to 0. 0 is the lower bound, okay, and you put end here, and then, okay, also you can take this Control C and put an end, Control V, J plus M smaller or equal than 20, smaller than or equal than 20, then, okay, so let's expand this, and then exit do and if, okay, and loop. So let's see what we have here. So we have a do loop, okay, let's indent it so we can see it better. Okay, so if so we run an infinite loop in which we cast the dice twice. The M and N dice are cast twice, and then verify if the new position is within the bounds, so greater or equal than 0 or smaller or equal than 20, then exit the loop. If not, continue casting these dice till you get the M and N of the correct sign that they stay within the bounds. So, and then of course you use M and N here. So we did very little modification. We essentially added this 5 lines, 1, 2, 3, 4, 5, and this should keep us within the bounds. So let's assign macro. Okay, this is let me see, bound. Let me see how we call this. Cancel. Oh, we have the same name, so let's call it bound. Okay, we would have gotten an error. So we go here to this and assign macro bound. Okay, here. Okay, always set it before and then run it, and this will keep the atoms within the bounds. You're not gonna have any leak on the side, on the edges, on the boundary. Okay, let's stop this and introduce a new variable. Let's say dim max, no, array ARR size as integer. Okay, so we will set int array size here. No, let's not say array size, let's say spacing, atom spacing. Okay, you can put array size too, but right now I made it 21 by 21. So atom spacing, atom spacing. Okay, Control C, and we go here in this set array. Okay, and put let me see, let's put Control V here, atom spacing, and W26, let's say 3, okay, or let's say 4. Okay, so W26, you go here in and say atom spacing, Control V, is equal to W26. Is it W26? It is W26. Okay, and then here we can put atom spacing instead of modulo 2, we could modulo atom spacing. So let's do set, oops, let me see, set, go here. Okay, I messed up, I'm sorry. Here, instead of putting atom spacing, Control V, equal to 0. Okay, it's not modulo 2 is equal atom space. So I modulo atom spacing is equal to 0, J modulo atom spacing is equal to 0. So we can change that easily. If we run bound simulation, it's nice to be able to space the atoms a lot, so we can follow each individual atom. Okay, so let's go set it and run. Okay, let's interrupt this and put here I don't know, 10. Okay, we only get one at actually let's put 8. Okay, set, let's put this 9, set 12. Okay, set, run. Okay, so now you can see very clearly how this is bound. You know, I mean, the movement is correct. The atom vibrates kind of and drifts around, and it hits the boundaries, and you don't have any leakage of atoms. You know, so let's stop this and set this at say 3. Okay, set it and run it. Okay, it runs. This is the longest video. Okay, the next one is very little. I mean, to implement polymerization and also maybe explain a few more details how to make it nicer. That's gonna be a fairly short video, less than an hour, probably less than. Actually, polymerization can be solved in 5 minutes or 10 minutes, 5 minutes I would say. And then the next video is not going to be so long, and I'm going to talk a little bit about how to make this nicer. You don't need to watch that, because from now on, I mean, by the time you know how to implement the polymerization, you can finish this. Okay, all right, thanks for your attention, and I will see you in the next video.